Excellent. Hi, everybody. I am Cristina. I am a data scientist with ATKI. ATKI is a company based in London. Our goal is to identify and mitigate algorithmic bias. We are a fairly diverse team. Our founders are, we're founded by two amazing women who are determined to make algorithms provide kind of the fair outcomes that we all deserve. I think there's been quite a bit of news lately about failures of machine learning algorithms to provide fair or ethical outcomes. And I wanted to give you 3 examples here. One of them, just to illustrate kind of a couple of points about this problem. So the first one here is about Steve Wozniak. His wife got a 10 times lower credit card limit when Apple released their credit card recently, even though they share assets and accounts. Most embarrassingly, Steve Wozniak is a co-founder of Apple. Another similar example is Amazon had to ditch their recruitment tool that made good use of ML algorithms because it was mainly recommending males and not females to be hired. And what's kind of surprising about these 2 examples is that they come from very established companies with amazing resources. However, I would say that the question of whether the algorithms that companies adopt are fair is a fairly new question for everybody, and it is a tricky question. So companies have to be kind of dedicated to addressing it, and that's, I think, where we at AT want to come in and help. Another example that is maybe even more disturbing because it has such negative impact on people's life is the bias in policing in algorithms employed in criminal justice in the US. Here we have an example where somebody who is Black was considered a lot more dangerous than a person, was predicted to be a lot more dangerous than a person who was obviously definitely a higher risk. So just to summarize, when we have unfair ML algorithms being deployed in the real world, both customers and businesses kind of lose. So customers lose opportunities. If these ML algorithms decide for them that they shouldn't get a mortgage because they're likely to not pay it, or they shouldn't get a better credit card, customers lose the opportunities to kind of move their life forward. We also, as people living in a society, we lose the chance to improve on historical bias that already exists in our society. And we lose a lot of time and effort dealing with these automatic decision-making systems that are unfair and trying to figure out how to correct them. And businesses also lose because they shut off whole customer segments that might otherwise be very productive for them. They have to deal with a public relation backlash due to when the community figures out that their algorithms are actually biased. And of course, in the cases in which these companies employ models in, let's say, in financial systems, there is a very real possibility of regulatory fines. So what I want you to, and hopefully you will take away from my talk, is that there are many sources of bias that are embedded in machine learning algorithms. And as a consumer of machine learning algorithms, as a user of their predictions, I wanted you to be aware of them and think about them when you use these predictions. If people in the audience are tempted to build their own machine learning algorithms, maybe they're at the beginning of their data science career or their data analyst career, I'm hoping to kind of raise awareness that this is an issue that you should pay attention to. So the way I'm going to do this is to kind of through a little exercise, basically. So I'm going to demonstrate to you the general steps that people take to deploy a machine learning algorithm. And then I'm going to show you an example in which these steps lead to very biased outcomes. And I have a few slides on how I think might help you identify these biased outcomes. And then finally conclude with some lessons learned. So let's see, I'm not sure if kind of the background of people in the audience, but just very generally, building a machine learning algorithm is all about training a model to learn features. So what you know about your clients, for example, you have clients that have different years of work experience, and they have different types of jobs and different types of certifications, and they have different, and what you want to know if their salary is over or under, I don't know, $55,000 or whatever, a limit. So you have to train your machine learning algorithm by providing it labeled data. So you provide labels for each customer you've had in the past that you want to train with. And ultimately what you're going to get from it is a model where if you input some defining features, these are the that you know about your new customers, you want to know, okay, does this model predict that their salary is over or under the threshold? And this sort of learning applies to anything you might want to predict, whether you want to predict whether you should send somebody some marketing, whether you want to predict if you want to, if this person is going to be a good renter for you. Whatever you want to predict, you have to learn from previous cases in which you had customers and their outcomes. What data scientists mostly do is they want to build models that are extremely accurate. And that's kind of the focus of the field, because that has been in the past the only metric used to evaluate these models. And what we realize nowadays that we should do is that we don't only want to have models that are accurate, we also want to have models that are fair. And if these predictions from the models are not fair, then we want to identify the sources of bias that we unfortunately have in the model and address them as much as possible. And I will kind of tell you a couple of definitions of fairness, but just to kind of give you an idea is one way of thinking if the model is fair or not is we want to know, okay, if for this group of for one group of people, 10 of them would have paid off their loan. Are we identifying those 10 people that would have paid off their loan or not? Are we more accurate in identifying the people who would have paid off their loan in a certain group of people based on protected attributes like gender or age? And are we kind of just as fair towards all these groups, or are we better predicting the outcomes for a certain group and make more mistakes for other groups? That would be an unfair outcome. So common sources of bias in machine learning algorithms. One is sample size disparity. So a lot of people train their machine algorithms without care of including in their training set examples from a diverse group of people. So for example, people trained algorithms to detect faces without including faces from minorities in the US. So in order to have an algorithm that performs just as well for everybody, we have to train them. We have to train this algorithm with a data set that has sufficient examples from every category we we're going to make predictions for. Another source of unintended bias that kind of just sneaks up on people is proxies, which means that even if a machine learning algorithm was not trained on, let's say, gender data or age data, gender and age and other protected attributes are correlated a lot with other features or other values you might have in your data set. And so you might end up with a model that is very biased, simply because the information related to gender is still baked into your data set, even if you don't have gender directly as a predictor in your model. So, I would always look at what are the features used to predict the outcome, and are these features likely to be correlated with a protected attribute like gender or age? Limited features is the example I'll illustrate more right now. And let's get right into it. And I'm not going to talk much about the last two, which are fairly complicated. So the way to kind of illustrate to you how this particular source of bias works is I'm going to build a data set, and I'm going to bake into it a couple biases and show you how, if you just use kind of the standard tools of machine learning, of data science, you'll miss the detecting the fact that the algorithm is unfair. So let's see. So here I'm just, again, I'm showing you the data set I showed before, which is I'm building a data set in which I want to predict from different applicants if their salary is over or under a certain threshold. And I get some data from, about these applicants. I know their gender, there's years of work experience, what kind of job they had, if they were a front-end or a back-end developer, if they had additional certifications in their salary. And, this data set looks like any other data set. The salary increases with years of work experience. It's balanced. So the average salary for male and female, which might not always be the case, is the same. People with a back-end developer job make just slightly more than a front-end developer job. So it's all fairly balanced. What I want to do is to introduce a couple biases. So first, whether a person has additional certification is very correlated with them being a female. And then second, for a certain group of females, so female developers with back-end development jobs and 7 to 15 years of work experience, I calculate their salary from a completely different, using a completely different process than the variables that I use to collect for all the other employees. And this kind of model captures a problem with keeping with machine learning algorithms, which is we know that we have to kind of get a training data set to train our models that is reflective of the world. But we often collect variables that are reflective of the outcomes of the majority. So if we know, if we only think about the majority and we think, what is a good predictor of the outcome for that person, then we'll collect that data. But we don't think about, let's say, people in other subgroups. What would be a good predictor for them? And so we know far less about, and we're able far less to predict outcomes for people outside of the majority. So here we're unable to predict outcomes that well for a certain group of females. And if you look again at how the average statistics for the data set, you wouldn't know anything changed at all. Things are fairly similar to the initial data set. So just my point here, and I guess my key point is that just the standard process of looking at machine learning algorithms and just evaluating them using basic exploratory data analysis like we've done in the past is not enough to showcase the biases. Here I look at metrics that are very common in the field, like accuracy and percent of positive labels, and they don't show a huge discrepancy. However, when I use fairness metrics, I can see that I use two different metrics, and I can see that there is a gap in equal opportunity between males and females that I should address. And so having this mindset of I want to design fair algorithms is very important, and then reaching for tools provided for this case. For example, using fairness metrics such as demographic parity and equal opportunity is crucial. So just to kind of give you a short kind of brief explanation of what this most common fairness metric is, the equal opportunity, as the name suggests, considers every correct positive prediction as an opportunity. So it looks at, do you offer the same opportunities for, in our case, males and females? So if, so do you make more mistakes for females? In that case, you will, if you're, for example, deciding on giving them a loan, you're not giving females the same opportunity as for males. So what we do at ETIC is we've realized that this is kind of identifying and mitigating bias is a tricky problem, and not all businesses want to kind of dig deep into it, or don't have the resources to kind of pay attention to this and give this problem the resources that it needs. So we want to provide an interface in which we at ETIC build the metrics and calculate the metrics and improve the models as much as possible. And we allow businesses to kind of quickly identify what are the problems with their models. Here I'm showing you a screenshot of one of our products. Here we show that for the particular data set that I discussed before, well, we have some, we have to worry about proxies, and we don't have to worry about sample size disparity. Something else that we do at ETIC is we debias models, which to the best of our abilities, which means we try to help our customers get to machine learning models that are more fair. So there's a lot of, I think, a lot of people in data science now that have realized that we have to check if the models are fair, but and kind of a logical next step is, okay, if your models are not fair, what do we do? So we want to help people build fairer models by providing them with a debiasing solution. Okay, so to just kind of summarize, if you want to have a fair algorithm, and I hope that my first slides with companies that decided not to were kind of warning enough, you should know that exploratory data analysis is not enough, and then you should use the tools that are specific to fair ML, to the fair ML field, such as fairness metrics, to see if there are further problems that need to be investigating. So actually, also wanted to conclude by saying this attempt to improve the fairness of our machine learning models will have long-lasting consequences. We always train models on historical data, and if we don't do anything to collect more fair data, our models will just perpetuate the historical biases that are already kind of baked in our society. So I think we have this great opportunity to improve things by feeding and training the models on kind of more fair data. Okay, I think my presentation was a little bit more technical than maybe the ideal at this time. So let me know if you have any questions about it, I'm happy to provide more explanations. Yeah, I'm happy to answer any questions. Thank you.
Thanks very much, Cristina. That was really, really insightful. Dive into one of the questions that David asked. When you talk to companies and you show them some examples of the bias, how do they react to it? How do they receive it? Are they positive? Do they want to change it? You know, is it unintentional, or do they ignore it?
It varies. I think it depends on the context of a company. Some companies are under regulatory pressure to provide, fair outcomes, and so they're more motivated to work on this problem. But I think all companies kind of want to improve the fairness of their machine learning models. The question is, what is the cost? So in cost in the terms of the drop in accuracy, or so we just need to find for each company the kind of the sweet spot of how much they want to improve their training data set versus how comfortable they are with kind of getting a data that's very different from what they historically got.
A question from Aparna. I mean, you can read it in the chat as well if you like. After she sent this to all panelists. But do you think it's important that companies hire people who are aware of these algorithms, historians, philosophers, social activists, but they're actually from a diverse background themselves, so they're much more aware of it. It's ingrained into them, the inequalities, so they're aware, they're not just having to learn it.
Yeah, absolutely. That is a great way to kind of check for model fairness, because you have to check. So I was trying to demonstrate that if you don't check if your algorithms are fair, then you can just happily deploy an unfair algorithm. And I think people that come from diverse backgrounds are more likely to check to see what kind of prediction does this model do for themselves or for their group. Yeah.
Brilliant. Well, thanks very much. We won't keep you any longer. We all appreciate the time you've committed to this and to come on at this hour. If we have another event, we'll make sure it's much more friendly time-wise, and it was a completely unbiased time schedule, I can promise you. We'll be aware next time.
That's great. I was happy to talk, and yeah, our company is based in London, and I'm fairly used to the UK time. It's fun. Okay,
Brilliant.
thank you.
Thanks very much.